Hey guys, welcome back to Data Products. In this class, this video, we're going to be working on some time series data. So let's just jump right on into it. Okay, so we ended off on the normal distribution, the Shapiro-Wilk test. Now we're going to be doing time series data. So first, let's load our packages. Library read R, and library read XL, air data read XLSX, air quality is that V or U? UCI.XLXS. And I need quotation marks. All right. There we go. Okay, so we have now air quality data. So we have carbon monoxide, nitrous oxide, all these other gases, nitrogen, etc. In this data set. And the time of day, etc. But what's most important about this data set is it's hourly, right? So we have every hour this is being measured, and we need that for time series data, right? Okay, so let's define some of these things. Date of measurement, time of measurement, CO, GT, average, hourly, CO2, and that's in milligrams per meter. The PT 08.S1CO, that is tin oxide hourly average sensor response. Then we have NMHC is the average hourly non-metallic hydrocarbon concentration. This is just to get you guys the opportunity, to look at this data and actually know what some of these things mean. We have the hourly benzene concentration, PTO 8.S2, NMHC, titania average hourly sensor response, NOx average hourly NOx concentration, NO2 average hourly NO2 concentration, T temp, RH relative humidity, AH absolute humidity. Okay. So instead of just graphing stuff that you don't know what they mean, let's get you some definitions for these things. All right. So let's look at the structure of this data set. So you can see these are things that we define them up here, what they actually are. These are measurements. We have date, we have time, etc. Perfect. So now let's load a couple packages. We've loaded them above, but if you're just doing this portion of the video or something, we'll load them again. It doesn't hurt to load them again. tidyr and dplyr. Okay. And actually we want to add a few more here. Library libradate, library HMS, and library ggplot2. Okay, so let's run these. Beautiful. Let's get rid of the date and the time column. So if we look at this, if we look at our date, we have our date here, and then we have also a date in this column, right? We have two dates, and one of them's like it says it's from 1899, which is not correct. This date's all messed up, so we want to remove that. So we can do that with the, if we do air data time, we say as HMS, so hour, minute, second, air data time. Now let's like take a glimpse of air data. Remember, glimpse is just another way to look at it. Okay, so now you see that our time is an actual time, and it got rid of this, whatever these numbers are all the same. I don't know what they mean. so we got rid of them. So we're keeping the date 3/10/2014 or 2004, excuse me, and then we added time. All right, so let's plot air data AH, so the absolute humidity, air data RH main equals humidity analysis, X lab equals absolute humidity, and then Y lab equals relative humidity. Oh, and how about we put those in our chunk, huh? Alright, let's see what we got. Interesting, so we have an outlier that is really messing this up. So, let's write that. Notice we have an outlier in our data. So let's run a t-test here. T.test air data RH air data AH. Air data not found. Oh. There we go. Okay, so if we were to look at these, we can see that the p-value is quite high, so we can say that the mean of these two, the relative humidity and the absolute humidity, are significantly different. But what we have an issue here is that we have this outlier, right? So we have one or a few that are exactly the same at negative 200 all the time. So if we look at, what was this, the air data? Okay, and that was absolute humidity. So if you look, we have a whole bunch, for some reason, that, I don't know if the sensors are broken on that data or something, that are all negative 200 for everything. Temperature, everything is negative 200. So that is going to be a perfect segue into our last section, where we are going to finish up our exploratory data analysis with the Grubs test. And so the Grubs test checks for outliers, and we will be able to remove them. So this kind of sets up our problem for our last video. This was a short one, 12 minutes. So we will check for outliers, or we will identify those outliers without having to do, if we were to use that spreadsheet and go through it manually, remove stuff, it would be a pain in the butt because there's a lot of them in there interspersed throughout there. So using R to remove them would be hard. But we'll have the Grubs test, be able to check for outliers. We'll be able to remove those because, as you can see, we really messed up our graph, right? So we really couldn't see what was going on. We had to use a t-test to see, to do that, or we can use a correlation to see if they're related. Without rambling too much, if you enjoyed this video, hit like, hit subscribe. We'll be doing the Grubs test for outlier detection in the next one. I appreciate you watching, and I will catch you in the next one.